2016 paper 2 question 1 line. So here in this triangle we're given 3 points A, B and C, and we know all of the 3 coordinates, and we're asked to find the equation of the line through B that's perpendicular to AC. So if we draw the diagram, or we draw the line through B perpendicular to AC, we can see that the line that we're looking for. So we have a point on the line, it's the point B. So all we need to do to find the equation of the line is to find the slope of the line. And of course, if the line is perpendicular to AC, then to get the slope of the line perpendicular to AC, we first of all need to know the slope of AC. So that's where we're going to start with this question. So we have the point A is 6 minus 2, and the point C is minus 3, 4. So if I call them x1, y1 and x2, y2, and remember it doesn't matter which is x1, y1 and which one is x2, y2, it'll still give me the same answer for my slope. And my slope formula can be found on page 18 in my maths tables. So subbing in our values, we end up with y2 minus 2 over x2 minus 6. So that gives me 4 plus 2, which is 6, over minus 3 minus 6, which is minus 9. So my slope, therefore, is minus 2 over 3. So therefore, the perpendicular slope, the one that we're looking for, that's going to help us find the equation of the line perpendicular to AC. Well, all I have to do to get the perpendicular slope is turn the slope upside down and change the sign. So therefore, my perpendicular slope is 3 over 2. So therefore, to find the equation of the line, well, the equation of the line formula, again, is on page 18 of our maths table. So it's y minus y1 equals m times x minus x1. So again, page 18. And of course, we have to make sure we're putting in the correct point and the correct slope. So our perpendicular slope here is 3 over 2. And the point that is on this line, if we go back up here, this is why our diagram is so important, that we mark in clearly that it's the point B that we are subbing in here. So it's 5, 3 is going to be our x1 and our y1. So x1, y1. So putting into the equation, we have y minus y1 equals m times x minus x1. So of course we want to tidy that up and write it in the form of ax plus by plus c. So I'm going to multiply everything across by 2. So it gives me 2y minus 6 is equal to 3 times x minus 5. And then multiply out my brackets. So I have 2y minus 6 is equal to 3x minus 15. And I'm going to write it in the form of ax plus by. And then we have adding 6 to both sides would be minus 15 plus 6, which is, of course, minus 9. So therefore, that's the equation of the line through B perpendicular to AC. So there was 10 marks going for that question. So it was broken down into 0, 3, 7, and 10. So in B, we're asked here to find the coordinates. So again, the x and the y value of the orthocenter of the triangle of ABC. So we have to remind ourselves, what's the orthocenter of a triangle? So the orthocenter is the point of intersection of the altitudes of the triangle. So of course, well, we need to know what an altitude is if we want to find the point of intersection of the altitude. So the altitude, of course, is the perpendicular line from the vertex to the opposite side of the triangle. So the line that we have just found in the first part of the question was from B to the opposite side AC, and it was perpendicular. So basically this line here is an altitude. So if we want to find the point of intersection of the altitudes, we basically need to find one other altitude. So we could get the altitude of BC, or we could get the altitude of BA. So either of those will work. And then to get the point of intersection of the altitudes, all we're going to end up doing is simultaneous equations. So if we look at getting the altitude from A to BC, well, what we'd find is that the perpendicular line actually falls outside of the triangle. So we'd have to extend that line across to do that. And same with the altitude from C to the side AB. We would have to extend that line to find that point of that perpendicular line. And then, of course, we can see when we draw the 3 altitudes where they meet is going to be our point of intersection, which is our orthocenter. So by doing our little sketch, we will expect this orthocenter to actually fall outside of the triangle because it's an obtuse triangle. Okay, so I'm going to choose one other side. So the side that I'm going to work with is the side BC. So B is the point 5,3 and C is the point -3, 4. So if I get the slope, so exactly as we did in the first part of the question, we're going to get the slope and then get the perpendicular slope. So that gives me m is equal to y2 minus y1 over x2 minus x1. So we have 1 over -8. So therefore our perpendicular slope, turn it upside down and change the sign, which just gives me 8. So in other words, the equation of the line, and we have to go, I've just taken BC, so that means that the perpendicular line to BC has to pass through the point A. So we are always going from the vertex to the opposite side for our altitude. So again, we always have to make sure our sketch is clear so we know when we're getting the equation of the line, in other words, the equation of the altitude, that we're putting in the correct points. So it's y minus y1 equals m times x minus x1. And I'm always going to write down my slope and my point next to it, so I have the correct numbers subbed in. So x1, y1. So subbing in then we have y minus y1, so that's -2, m times x minus x1. So we have y plus 2 equals 8x minus 48. So that's 8x minus y minus 50 equals 0. So that is my second equation of an altitude. Now, if I was to do the side AB, through the point C, so in other words the other altitude, it works out to be x minus 5y plus 23 equals 0. Okay, so just as a side note for anyone who has done that point, that's what you should be getting for the third altitude. So I'm now going to take these two altitudes and I'm going to get the point of intersection in order to find the orthocenter. So the point of intersection equals the orthocenter. So my first equation there was 3x minus 2y minus 9. So I'm just going to bring the 9 to the right hand side. And we had 8x minus y minus 50 equals 0. So again, if I bring the 50 to the other side, and we end up with our two simultaneous equations. I'm going to multiply the second equation there by -2. So that gives me 3x minus 2y equals 9. And then I have minus 16x plus 2y equals minus 100. So making sure you're multiplying both sides there by -2. So that allows me to cancel my y's, which leaves me with 3x minus 16x, which is minus 13x, and 9 minus 100, which is minus 91. Dividing both sides across by minus 13, that gives me x is equal to 7. So of course I have to get the coordinates of the orthocenter, so I must also find the y value. So I'm going to sub x into the second equation there, because it doesn't make a difference, but there's no coefficient in front of y, so it makes it a little bit easier. So I have 8x, so 8 times 7, minus y equals 50, and that gives me 56 minus y equals 50. So we end up with minus y is equal to 50 minus 56, which is minus 6, and therefore y is equal to 6. So that means that the orthocenter is 7, 6. And there was 15 marks going for that, and it was broken down into 4 parts. So we had 4, 7, 11 and 15. So again, if we go back to our sketch, we should see that we are getting a value 7, 6 if we've drawn it accurately, okay? So if we've graphed it properly, we should be able to get it clearly from our sketch.